Hello, everyone, and welcome. This is Professor Thayer with you here today to talk to you about looping. So we're going to cover this over the course of a week. We'll start off by talking about some of the for loops, and we will see a variety of examples over the course of our week. So let's go ahead and get started. Oops. So we'll see the for loops with the strings, we'll see for loops with range, we'll see loops with numerical indices, string processing. So we've already seen the while loops, but we can see how the while loops can be used specifically for processing strings. Then we'll see some more looping examples. It kind of mixes the things up because we have seen a number of different kinds of looping. And finally, we'll see a intricate version of loops. That is, if I give you a for loop, can you turn it into a while loop, or for X and range kind of a loop, and vice versa to switch it all around. So it takes a little bit of practice. Hopefully those will help get you on the right foot. All right, so let's take a look at for loops and strings. So we can have for and the variable in string, and then we will have our body here. Now, the interesting thing about this is that this variable will be our loop variable, and this will actually become the character in the string. So unlike needing to go and advance with the looping like we did in the while loop, the advancement happens automatically when we are doing the string processing. So let's take a look at an example of how this might work. So here we have a string X equals A, B, C, D, E, F, G. So what we're going to do is we're going to do for I in X. Now I will stand for our index. Of course, you could use any loop variable of your choice, but let's choose something that's going to be helpful. So we will call it I for index in X, and then we will print I. So as we step through this, I will begin automatically being equal to the first character in the string, so it will be equal to A. And then we will print the current value of I, which is the letter for the character A. Then we go back to the top of the loop, and we see that I now is going to point to B because that's the second character in the string. And so that is updated in the variable table. Now we will print the current value of I, which is B. Back to the top of the loop, the pointer has advanced now to C. So we'll print C. And so on with D, E, F, cycle through, print F, right? Okay, back to the top. That pointer is now pointing to the final character G. We will print G, and the pointer is no longer able to advance because that is the end of the string. So the loop automatically terminates. Notice that there's no branch guard for this. So we've seen branch guards as a way of the loop terminating, but the looping terminates automatically when the string has been fully processed. So let's just take a look at this in a little bit more detail. For loops with strings will process each character in a string in turn. This is a very common task. We already saw looping with the while and counter to do it. And so a simplified looping construct exists. That's the for loops, which does a lot of the work for you. It automatically assigns each character to the string to the loop variable in turn as we cycle over that string. So we'll have, again, for, and then the loop variable in, and then the string. So you'll have a variable name here, follows all the Python normal conventions, and here is a string. It's nothing special about this variable. Oftentimes we should choose something that makes sense, but there's no Python enforced restrictions on it. And then we'll have our loop body here, which may contain any number of lines of code. So for example, we might have for character in Erie, and then we can print the character. So here we are, we'll come through this loop, and the character will point to the first one in the string. So that points to E. Print character, that's how we got the C over here, back to the top. Next, we move on to the next character, R. So the character now equals R, and we print current value character, which is R, back to the top. This pointer moves over by 1. So now character equals I. We print character, which is I, back to the top. And as you might have guessed by now, character will now be equal to E, which we print. And then there are no more characters, and that's the end of processing this string. So we see that it will cycle over this in that way. Notice what we are showing here is this is actually a string here. We've also seen it in the slide before where you have a variable that's equal to a string. Python really doesn't care how it receives that. It just needs to get the type of string. All right, so here we have a spot the bug problem for you to try. So here is a string bug problem. This takes in an input S of type string. It returns none-type. It's going to print each character of S. All right, we have I equals 0 for I in S, print S of I plus equals 1. Here's our function call that will make our function actually execute. And so it should just print out each of the characters of the string, right? Do you see anything not quite right about this? Why don't you go ahead and pause this video and you can work with your neighbor and see if you can identify what might be wrong. Back here in a few minutes. All right, I hope you had the chance to chat with your neighbor about this problem. Let's take a look and see if we can identify what the problem might be. So here we have string is the input type. I see we have a string down here, so that looks fine. And we see also that it's returning none type. Now, we do notice that the function is returning none type. So remember when we talked about our functions, what are the way that functions can terminate? Well, they all terminate with a return. It's just that sometimes the return is implicit. So this must be an implicit return because I don't see any return actually explicitly written here. So this will be an implicit return and it will also be returning none. So there were several problems with the loop before. Let's take a look at this. I see that the loop was initialized with an I equals 0 and then for I in S. So the initialization is really quite superfluous here. The reason for that is because when we're cycling over the string with the for loop, the I will take on the value of the string independently, right? So we don't even have to do that. So by setting I equals to 0, that simply just gets overwritten and we don't even do anything with the I equals 0. So it's really not needed. So we get rid of that. Also, we might want to change this to be CHAR for character in string. It's a good idea to, to choose a mnemonic device for our variable. And the reason is so that it will make sense. It will jog our memory and we'll be like, ah, yes, it sounds kind of like what it is. It's the character. And you are less likely to make the mistake that you're thinking that the character is numeric. So that's really great. We have changed that. So that's technically not anything wrong with it before, but this is certainly something that will upgrade it and make it better. Then we will simply print the character. Okay, now there were some interesting things that we saw here. We see print S of I. So this looks like slicing. And actually, we're going to see that the slicing can be used with the numeric indices, but we don't need it. The while loops, the for loops are going to automatically move the pointer to the next position, and the value of the loop variable is the character itself. It's very simple. So the S of I is not even needed. We can simply just print the I itself. So that's what we have here. Now, notice that we also had the incrementation of the index. You know, and this looks actually pretty good if you looked at it at first glance, right? You have initialization, some looping, and then you increment your index, right? Which would make a lot of sense for the while loops, but not for the for loops. You don't need to do that. There's no need to do that. And in fact, if you leave this in, what will happen is that it causes I to now become well, to get, okay, so what will be the type, right? So you have I is equal to some character, and then it's being plus equal to 1. Is it going to get coerced into another number if I is pointing to a character that happens to be numeric? I mean, what's going to happen? You can see where the overloading could get out of control very quickly here. And it's likely that we will encounter some kind of a wrong type here. This is definitely an accident waiting to happen. And you don't need it because the index is, again, just incrementing all along by itself. You don't need any variable incrementation explicitly because all of that is just happening all by itself. So that's all you need. And then we have here the function call. That's the name of the function. And then we will send up hello world. And it's supposed to print out each character, which we can see over in the output up here. And there we have it. So great. So I also want to talk to you about string processing and accumulation, because this is a common theme that we're going to use in the string processing. We're going to have some kind of an accumulator. What's an accumulator? It's kind of like a bag that you're going to put things into as you're going along. It's like a shopping cart where you collect things as you're going through the store. Suppose you want to collect characters as you are cycling over the string. Maybe you have some kind of if statement or something that is going to say, okay, I do want this character, or no, I don't want it. I'm not going to collect that one. The accumulator is the variable that will collect the things that you're going to keep. Now, when you're doing this, the accumulator is not really any kind of special variable in the sense of like a Python type. It is more an idea of how the variable is being used. And so we want to just keep that in mind. So let's see what we have here. An accumulator can be used to capture some set of characters as we are processing a string. The accumulator is a kind of variable, not a specific Python type, as we were saying. Any valid Python variable name may be used, but ACC is often chosen as the mnemonic device so we'll easily remember what it does, accumulating things. It's often used with if statements as a condition for accumulating. So you might have, if it's an uppercase, if it's a lowercase, if, it's preceded by a vowel, if, and you can go on and on to make variations of this. But the idea is if you want to collect some characters, but not all of the characters, then it would be a good idea to have some kind of if statement to make that decision. The accumulation occurs by concatenation when you're processing strings. So we've seen running totals in the shopping cart problem. And so that would be done with some total that is going to add things up over the course of shopping. So that would be a numeric one because we're probably talking about dollars. But the accumulation in a string processing is going to be the string, right? So you're going to collect it into another string if you're going to keep it. And that will happen by concatenation. And oftentimes we can use augmented assignment, ACC plus equals something. And so that's how we will be using this. So let's just take a look at this character accumulation here. We have a function called get alpha of s. It's going to take in a string and return a string. We see it's returning an accumulator right here. Selects out only alphabetic characters from a string. So don't forget that we have now already seen all of these methods for working on these strings. So we're going to make use of the is alpha, which will return true or false. So remember, we'll be using the dot notation with that. So if we have an empty string, right, for our accumulator, we're going to cycle over the characters in the input string. So here's an input string in our function call. So for character in S, that is, we're going to be pointing to each of these, the accumulator will be added, we'll have the character added on if the character is alphabetic. So just taking a look at this right here, we can see pretty quickly that D-I-C-E should spell out the word dice, which is how we get the answer over here. But how do we get Python to say that? That's a little harder. So it's because of this if statement. If the character is alphabetic, then we will accumulate that character. So let's step through how this would work. So Python imaginary pointer runs down and it learns how to get alpha, but it doesn't run yet because it hasn't been called. Oh, here's a print statement, and inside that print statement, we have a function call. All right, let me go and run the function. Here's my string that I'm going to send up. So this string of characters gets sent into S, and we are in the def line. Now we proceed on to setting the accumulator to be the empty string. Now for character in S, so our pointer is now been set to this 1. For character in S, if character dot is alpha, so is 1 alphabetic? It is not, so the if statement is false, and we go back up to the top. Why is it we don't go to the return? Because of the indentation, right? So now we're back in the for loop, and the pointer has advanced to the next character, to the 2. So again, we will check to see if the character is alphabetic, which it is not. So we won't accumulate anything. We try for the 3 as we go through the loop again, which again will give a false. And we go back to the top, and now we get the dash. Is the dash alphabetic? Nope, it's not. So again, we move on to the next. Oh, it's a D now. So character equals D if character dot is alpha. Ding, ding, ding. Yes, it is. So now we're going to have the accumulator, which is the empty string, adding on to it the character D, which is just past this branch guard. So we go back to the top, and now the next character is I. So if the I is alphabetic, which it is, we will accumulate that, right? Next time through, we will process the dash, which is not alphabetic, so we don't accumulate that because this is false. Back to the top. C, that is alphabetic, so we collect that. So now we have D-I-C of dice, and we go back to the top, and we move the pointer to the star, which is not alphabetic. Move on, now we get the E. So we will collect the E into our accumulator, and then we move the pointer to 4, which is not alphabetic, false. Move on to the final position 5, which is also not alphabetic. We see that there are no more positions to process, so we exit out of the loop automatically, and we see that now we are going to return the accumulator, which is now accumulated dice. And when we run this, okay, and so here's our function call. This is inside of the print statement, so the accumulator gets returned into print, and so that is how we print dice to the screen. All right, a lot of flow control in here, but this is how this works. All right, so here we have a mystery function. This is a fun problem. Mystery function crazy 8 performs the extraction of a secret message. Several examples of the mystery function input and output are shown. Write a mystery function that uses string processing to correctly decode the message. All right, so your job is to be a sleuth and figure out what the crazy 8 function actually needs to do here. So we see let's see if we can recognize the pattern. We call the function with this sentence here, and here's another example of this. They ate the whole cookie, but I see there's a number of digits in here, and they have collected, there's no spaces collected. The 8 is collected in the cookie, the whole, okay. So what is the pattern as to what is being saved here? Now we also see this one, meet me by the gate at 8 p.m. and we have saved meet me at 8. So it's not about numbers, because all these other numbers did get lost. So only the 8 gets collected. And it looks like capitals are collected. How could we write a function that would collect those things? So why don't you go ahead and pause the video and try this out, chat with your neighbor, and we'll turn back in a few moments. All right, well, I hope you had the chance to chat with your neighbor about this crazy eights problem. This is going to be something that can be solved with the processing of the string. So we're going to pass in a string S to our crazy 8 function, and then we're going to have an empty accumulator that will collect something. So now the things we want to collect are the parts we want to return. We notice that the pattern here is that capital letters and the number 8 are the only thing that is saved, and everything else is thrown away. So one thing we can do is we can screen for that the character is uppercase, because we know we should keep it. So if the character dot is upper, which will return true, then we would have the accumulator plus equals the character, so we would save that character. Then we can have elif character equals 8, the specific character 8. Then we can accumulate the 8. So this is how we save the 8s, but we will throw out all the other numeric characters. So the interesting thing we have here is that we have 2 branches. We have one branch that is collecting the capitals, and we have another branch which is collecting the number 8 specifically, and that is if they appear. So after this is processed, then we will return the accumulator. All right, well then, I hope that this was a helpful video for you in learning about the for loops. We will continue on our discussion of these loops in our next meeting. We'll see you soon. Bye-bye.